A warm welcome from World College of Technology and Management. I am Komal Saini, Assistant Professor Chemistry from the Department of Applied Sciences and Humanities. And today we will discuss about conformational isomers and some conformations of N-butane and cyclohexane. Let's start with the definition of conformational isomers. What are conformational isomers? Conformational isomers are those isomers which are interconvertible into each other by the rotation of carbon-carbon single bond. So let's start with N-butane. As you can see, butane. But means 4 carbons, N means single bond. ठीक है? Now structure हमें पहले बनाना पड़ेगा N-butane का. So we can draw like that: CH3, C, C, C. 4 carbons and all the hydrogens are attached to carbons. ठीक है? Now let's start with conformations of butane. The first conformation of butane is anti-conformation. So how can we draw this? And we are drawing all these structures in Newman's projection. Now many projections are there: Newman's, Sahor's, Fisher projection. We have to draw it in Newman's projection. So butane can be drawn into Newman's projection like that. So first जो आपका conformation है वो है anti-conformation. So we can draw like that: carbon C1, this carbon C1 and C2, carbon and CH3 is attached here, that is methyl group, and 2 hydrogens are also attached with it. Okay, then C2 is on opposite side of the ball, C2 and all the hydrogens, and CH3 is attached here. Okay, now what we have to do, we have to rotate this on 60 degree. Now assume that I am holding a ball and stick a reverse Y, that is this, here in front side and same other side. So we have to stabilize C1, that is carbon 1, and rotate carbon 2 at 60 degree angle. So you can see that we have to stabilize carbon 1, C1, and rotate carbon C2 at 60 degree rotation. So CH3 is here. After 60 degree rotation, it will come here. CH3 and hydrogens are also revolving with it. That's why CH3 comes here, and hydrogen. This rotation called gauche and skew. ठीक है? First conformation is anti, second conformation is gauche, or you can say it skew. Same thing, 60 degree rotation. Firstly, we have to stabilize carbon 1 and rotate carbon 2, that is C2. So firstly, we have to stabilize front one and rotate 60 degree again. So CH3 is here. After the rotation of 60 degrees, CH3 will come here. CH3 and hydrogen will also come here. Okay. Last conformation is fully eclipsed conformation. This one is partially eclipsed and this one is fully eclipsed. In this, after 60 degree rotation, CH3 come here, exact aligned with other CH3, which is CH3 of carbon 1. Now both the conformations are, is front and back one, are eclipsed. That means one upon another. That's why fully eclipsed conformation. These are mainly 4 conformation of N-butane. If we continue the rotation, what will happen? After 360 degree rotation, this structure will come. Okay, after this 360 degree rotation, we will get anti-conformation again. So these are the conformations of N-butane. If you want to draw energy diagram of this N-butane, what will you do? You have to draw energy in increasing order like that, and you can draw energy diagram like that. Okay, what will this graph show? This graph will show low energy here. That means which structure needs low energy to stabilize. As you can see, anti-conformation CH3 here. Steric hindrance is very less. That means structure is stable already. So we need less energy to stabilize it. So we have to draw anti-conformation here. Okay. After that, some all energy are required. Some energy is required in which? In gauche or skew. So you can draw here gauche and skew. You have to draw all these. Okay. And फर्स्टली जो भी पूरा बड़ा कर्व है, यानी कि एनर्जी ज़्यादा रिक्वायर्ड है, वी हैव टू ड्रॉ फुल्ली eclipsed because this is aligned one upon another. That's why this is very unstable because of static hindrance, or you can say static strain. Static strain, that's why we are showing it like that, fully eclipsed. If we are seeing energy order or stability order of this, energy order, so energy anti-conformation require less energy than gauche. After that, partially eclipsed conformation require energy. After that, eclipsed, last one eclipsed. Okay, as we can see, stability order of this, as we know, most stable conformation is anti, because steric hindrance or steric strain or torsional strain, you can say, is less in anti. So we can show the stability order like that. Anti is most stable than gauche, and partially eclipsed is more stable than this, and less is eclipsed. Okay, eclipsed is less stable in all the four conformations. Now let's start with conformation of cyclohexane. As you know that cyclohexane is nothing but a ring chain structure which has 6 carbons and 12 hydrogens. Okay, conformation means we can rotate the carbon-carbon single bond and conform it to another isomer. That is conformations. First conformation of cyclohexane is chair conformation. So we have to draw like that. You have to learn how to draw it. This chair conformation is drawn like that in this structure. Nothing is this carbon-carbon single bond rotation. Carbon, all the 6 carbons have 2 hydrogens attached. That's why 6 carbons and 12 hydrogens are there. This is chair conformation. As you can see, all the hydrogens are far away from each other. That's why steric strain is less in chair conformation. As you see, boat conformation. Boat conformation have these 2 hydrogens. They are called flagpole hydrogen. Flagpole hydrogen. They are connected to each other. Connected nearly to each other. That's why steric strain is more as compared to chair conformation. This boat conformation is more stable than chair conformation. Okay, but boat conformation has these flagpole hydrogens, and that's why steric strain is increased. So we can say steric strain is less, steric strain is more. Next conformation is twisted boat. Twisted boat is nothing. Let's assume I have a boat in my hand. Let's assume silicon boat. I have to rotate, I have to stabilize this part, and I have to rotate from this side. Okay, so I rotate this boat conformation. So that's why twisted boat. Name is suggested, twisted boat. Twisted boat. What will happen here? All the flagpole hydrogens are there, are far away in this structure. That's why boat conformation has less steric strain as compared to boat. Okay, first conformation is chair conformation, which is stable. After that, twisted boat conformation is stable. After that, boat conformation. Last conformation is half chair. Nothing like chair. Half chair, just name is half chair. Half chair is like submarine, like a water submarine. All the hydrogens are attached on this side. Okay, steric strength is very high in this structure. That's why, as we can see the stability order, chair conformation is more stable. After that, twisted boat. After that, boat conformation. Last one is half chair, that is least stable. Chair conformation is more stable. That's why it requires least energy to stabilize more. That's why energy order is chair. After that, twisted boat. After that, boat conformation. Last one is half chair. Half chair required more energy to get stabilized because of steric hindrance. Okay, if we have to draw an energy diagram of this, we can draw like this: half chair have, because half chair is more in steric strain. That's why we require more energy. That's why we are denoting half chair with high energy levels. Okay, there less energy is there. That's why chair conformation is there, because chair conformation is stable. That's why we are showing here with least energy. Chair conformation. After that, half chair, because of steric strain, it requires more energy. That's why high peak. After that, this peak will show twisted boat, and this small peak will show boat. Okay, thank you.